So this notes video will be on two-column proofs. We've already talked a little bit about two-column proofs in class, but I wanted you to have something to reference in your notes on them. And the two-column proofs that we did were really just for solving equations. So we're going to look at a proof that involves some geometry concepts that we've covered. So any properties, postulates, or theorems that we've learned this year may be used as justification in proofs. So the postulates at the beginning of the year about two lines intersecting in exactly one point, or perpendicular lines intersecting and forming a right angle. Vertical angles, any of those properties that we've covered up until now and that we continue to cover will be used in proofs. Actually, our next unit is all on angles, and we'll be doing some proofs in there as well. So I'm going to add some additional theorems to our list of theorems, I guess, and they're kind of intuitive, but I want to get them written down. So some additional theorems are the right angle congruence theorem, which is that all right angles are congruent. Kind of sounds like, duh, we know a right angle is 90 degrees, so another right angle also has to be 90 degrees, and if angles have the same measure, then they're obviously congruent. But you're going to need to reference some of these theorems, and so the name of the theorem is right angle congruence. If you said definition of right angle, that might work too, depending on the proof. Another one is congruent complements theorem, and I want you to make sure you write down the definition and draw the diagram for this one. So if two angles are complementary to the same angle, or they're complementary to congruent angles, then the angles themselves are congruent. And you can see here in the diagram that angle 1 and angle 2 are complementary as marked by the blue box in the corner, and angle 2 and angle 3 are also complementary as marked by the pink box. And since 1 and 3 are both complementary to angle 2, then they must be complementary themselves. If we made up numbers for this would be pretty obvious. I could say that angle 1 angle 2 is 30 degrees. Excuse my handwriting. Okay, if angle 2 is 30 degrees, then if we calculate angle 1 and angle 3, we would take 90 minus 30, so that would make angle 1 60, and that would also make angle 3 60, just by the definition of complementary. So if we know that two angles are complementary to the same angle, then those angles themselves must be complementary as well. So our congruent supplements theorem is if two angles are supplementary to the same angle or to congruent angles, then the angles themselves are congruent. So it's very similar to the congruent complements theorem, except for we're talking about angles now being supplementary. So if I look at angle 1 and angle 2, those clearly are supplementary angles right here because they form a straight line. And also angle 2 and angle 3 are clearly supplementary because they form a straight line, both of them being separate linear pairs. Since 1 is congruent to 2, so 1 is supplementary to 2, and 3 is also supplementary to 2, then 1 and 3 must be congruent. In the same way that I did this on the congruent complements one, I could give 2 an angle measure. I could say angle 2 is 100. If I treat 2 as 100, then to solve for 1, I would just take 180 minus 100, making 1 80 degrees. And then I could also do the same for angle 3, taking 180 minus 100, and that would also make 3 80 degrees. So this is really something that we could have figured out on our own without labeling it as a theorem, but when we reference it during proofs, we will need to call it congruent supplements theorem or congruent complements theorem. Okay, so now we're actually going to do a proof, but first I just want you to get down how we format a proof. So we talked about this in class. We'll basically make a T-chart for our proof. On the left-hand side, we're going to put the statements, and on the right-hand side, we will put the reasons. What I've put in red will basically always be the same for every single proof you do. Sometimes you see proofs that don't start off with the given, but we'll always start it off with the given just to be consistent. So this statements and reasons with the T-chart will always be in your proof. Also, whatever is given to you that you're going to use to prove, so what you're proving and what you're given will always be provided, and then you have to fill in the parts in between right here. So we'll start with what's given. It'll literally be labeled given. You'll see on the next proof how, a proof will be given to you to do. So it'll be labeled given. You would take whatever it was. The ones we did in class were equations. You would take that, put it right here, and then your reason for that will be given because it was literally given to you. Then in between here is where you would try to connect the given all the way to the conclusion, what you're trying to prove, which will also be provided to you, and you're going to have to justify with a property or with a theorem or with some kind of postulate, some reasoning. So this will be the format of our proofs. Make sure you pause and get this format down, and then we're going to do a proof on the next page. Okay, so our proof, notice here it says prove that if ray DB bisects angle ADC, then angle 2 is congruent to angle 3. So sometimes it will be given in a sentence, and it might also be given this part where it says given something, prove something. This will always be provided for you. So just like I showed you in the last one, we have our statements and we have our reasons. We're going to have 2 columns. That's why it's called a 2-column proof. And you're always going to start off with taking your given and putting it as your first statement. Now I want you, before I start doing the proof, make sure you pause the video, copy down the diagram, so because it won't all fit in the frame, and when I'm scrolling I want you to be able to look back at it. So pause, get down the given, the prove, and draw the diagram, and make sure you label it. Okay, so now to actually proving. First thing I'm going to do is I'm going to take my given and put it as my first statement. So here I've taken that ray DB bisects angle ADC. And my reason for that is going to be given. That was just provided for me. So now I'm trying to get all the way to saying that angle 2 is congruent to angle 3. Now, if we're starting with the fact that ray DB bisects angle ADC right here, then I want to start off with what does that mean to bisect. So we know that a bisector will cut either a segment or an angle into 2 congruent parts. So the next thing that I can say is that angle 1 is congruent to angle 2. My reason for that is it's a definition of a bisector. That's what bisector means. They told us it was a bisector, and that's what we can draw from that. So I know that 1 and 2 are congruent. I'm still trying to get to the fact that 2 and 3 are congruent. Now you might notice something about 1 and 3 right here, which we've talked about previously. We haven't gone over many angle relationships, and this was a big one that we used. And 1 and 3 are actually vertical. So we would say angle 1 and angle 3 are vertical angles, and this is the definition of vertical. So remember, our definition of vertical is that we have 2 intersecting lines, and the opposite angles are vertical angles. Okay, so the next thing we're going to say is what can we conclude when we know angles are vertical? We know that vertical angles are congruent. So now I can say that angle 1 and angle 3 are congruent, and this is the vertical angles theorem. You might think that this could be combined in one step, and I would be okay with that, but some of the problems we'll be doing will be filling in the blank. So a lot of times in proofs, they state like that they're actually vertical and then they say that they're congruent. Or another example would be stating that angles are supplementary and then saying that their measures add up to 180. So I want you to recognize that sometimes it may seem a little redundant, but we're really still just referencing vertical angles on both of these. We know that vertical angles are formed by the two intersecting lines, and we also know that they're congruent. So I can say that angle 1 and angle 3 are congruent. So I'm really almost there. I just said 1 and 2 are congruent. Now I'm saying 1 and 3 are congruent. And one of the properties that we covered in class allows me to now connect 3 and 2. So I know that 1 is congruent to 2 and 1 is congruent to 3. So I'm kind of taking out that middleman of 1 and connecting angle 3 to angle 2. And this is the transitive property. I told you about how the transitive property is linking. We have that link of angle 1, and so now I can basically just take angle 3 and angle 2 and put them together. Now, might think we're done with the proof. Again, sometimes you'll see proofs that just have a couple extra steps that I would not really require of you, but we still want to just recognize when they do have those steps. So if you saw like a fill in the blank question and it went from angle 3 is congruent to angle 2 and then it says angle 2 is congruent to angle 3, because if you look back at the top, that's the order that they had them in on the prove statement. So if you did see it this way, where really it just switched it around, we went over that property and we said that was the symmetric property. It's like saying x equals 5 or 5 equals x. If I switch around two things on an equal sign or on a congruent sign, it really means the same thing. So now we've concluded the proof. Like I said, I might take out this line right here and then the last line, but I just want you to recognize if there's extra steps, you can still provide reasons for them. And that concludes this notes video, so make sure you've paused and written everything down, and I'll see you in class.